All right, we're going to do the last set of problems on the Unit 5 review. So on number 23, we have a fraction and the exponent. And in order to get rid of a power that is a fraction, we're going to be raising it to the reciprocal power. So the reciprocal of, and if this was not by itself, the base with the exponent, we would actually first have to get that base by itself. But since it is all by itself, we're just going to raise it to the reciprocal power. The reciprocal of 1 over 3 is 3 over 1, or you could think of it as cubing it. So we're going to cube both sides. The 1/3 and the 3 will cancel out, so you're just left with 2a plus 3 equals 2 cubed, which is 8. And then it's just regular algebra. Subtract 3, so you have 2a equals 5, and then divide both sides by 2. So a equals 5 halves. All right, and then you could check your answer if you want to, but we really only need to do it on even roots, and this since is a cube root, that's odd, so we're good. Now let's go ahead and do number 24. This time we do have a square root, so we are going to have to check our answer at the end. Before we square both sides, so we're going to have to get the radical by itself. So that means I'm going to have to subtract 2 from both sides first. So you have the square root of 5x plus 1 equals 2x minus 2. Now that the radical is by itself, I'm going to go ahead and square both sides. Keep in mind, you cannot shower the power because this is not together by multiplication. This is actually together by subtraction, so you're going to have to multiply that out. Square and square root cancel each other out, so you have 5x plus 1. And remember, this is the same thing as saying 2x minus 2 times 2x minus 2. We're going to have to multiply that out. All right, so we have 5x plus 1. Multiplying this out, 2x times 2x is 4x squared. 2x times negative 2 is a negative 4x. Negative 2 times 2x is another negative 4x. Negative 2 times negative 2 is positive 4. Let's add our like terms over here. So we have 4x squared minus 8x plus 4. Now at this point, we need to get that to equal 0. We need this to equal 0 before we can factor it. So I'm going to bring everything over to the right since my x squared I want to be positive. So I'm going to subtract the 5x from both sides, then subtract the 1. That'll give me 0 on one side of the equation. 4x squared minus 13x plus 3 equals 0. All right, at that point, you're going to go ahead and factor it. So you could use a t-chart or go straight to 2 parentheses. Two things that make that multiply to get 4x squared is 4x and x. You could try 2 and 2. But I noticed that I have a 13 in the middle here. And if I multiply 4 times 3, that'll get me 12. And then an extra 1 will get me a 13. But I want it to be negative 13, so these are both going to be negative. So I have 4x minus 1 times x minus 3 equals 0. And at that point, we want to set each factor equal to 0 to solve. So here I would add 1, divide by 4, and here I would just add 3. Okay, these are my x values. Now, before you box your answer, you're going to have to check because this was an even root. Now, you could plug it all the way to the very beginning. What I'm going to look at is when did I get that radical by itself? Because a radical cannot equal, well, I should say a square root cannot equal a negative number. So I'm really going to just plug it into here to see if I get a negative number. 2 times 1/4 is going to get you 1/2. Actually, maybe I'll write it down so you can see. 2 times 1/4 minus 2. I'm going to see if this gets you a negative number because we do not want a radical or a square root to equal a negative number. 2 times 1/4, you could put this over 1, and then kind of think of it cross-canceling there. So it's 1/2 minus 2. Well, 1/2 minus 2 is negative 1/2, or you can say negative 3/2. So we can't have it be negative, so this is not a valid solution. Let's try 3. 2 times 3 minus 2. And again, we're plugging it into this step right here when the radical is by itself. 6 minus 2 is 4, and that's a positive number, so we are good. So x equals 3 is the only solution. All right, let's go ahead and look at number 25. So number 25, let's see if I can get this on the screen. We have another square root. So we are going to have to check our solutions on this one. So we have the square root of 3x plus 7 equals 5. You have to get the radical by itself by subtracting 7 first. And we have the square root of 3x equals negative 2. Can a square root ever equal a negative number? And the answer is no. You can go through and solve and then plug it in, but technically a square root cannot equal a negative number. Once that happens, we can say that there's no solution. If you get a solution and you plug it into x, it's going to be an extraneous solution. Okay. And then number 26, last one. So number 26, we again have a fraction in the exponent. We'll have to get that fraction to go away by raising it to the reciprocal power. All right, so let's go ahead and first isolate this base. This is the base I want to isolate. So I have to get rid of the 2 and the negative 5. You have to get rid of adding and subtracting first. PEMDAS backwards. Adding, subtracting first. Oh, what happened? Whoa, let me redo this. Something happened. All right, I think we got it back on track. Okay, so we have the x plus 4 raised to the 2/3 power equals 18. We still have to get rid of the 2, so we're going to divide both sides by 2, not 9. Divide by 2. This cancels. We have an x plus 4 raised to the 2/3 power equals an 18 divided by 2, that's a 2, is 9. All right, now at that point, we want to raise it to the reciprocal power. And the reciprocal of 2 over 3 is 3 over 2. So the 3's cancel, the 2's cancel. That's why we raise it to reciprocal power. This all becomes 1. So we just have x plus 4 by itself equals, now let's simplify. The root is what I'm going to do first. So this is square root of 9. And the square root of 9 is 3, but we're still going to cube that. And 3 cubed is 27. And the last step I'm going to do is subtract the 4. So we have x equals 23. And then if you look at the beginning problem, it was a cube root problem. So cube roots, we don't have to check our solution. That is your solution. Okay? All right, study hard tonight.